All right, y'all. So this is what you need to do for the statistics project. So at the very end, you need to create at least 9 slides. And I have provided this example slideshow for you. Um, you need a title slide. You need your question. And so I gave you that question. So in the statistics project, there's your name with your question. And so basically, what I did is I went through each data set and I looked at two things that kind of looked interesting to see if there was a relationship. So, for example, is there a relationship between someone's height in centimeters and their foot length in centimeters? I would think that the taller you are, your foot length would be bigger. But is there a mathematical relationship? That's what we need to look at. And so make sure you're paying attention to, do you have data set A or do you have data set B? You could see here that this is data set A, and data set A has to do with students in South Carolina. So this is actual data collected from South Carolina students. And you can see it dates all the way back to like 2012 is the earliest date I see. So it dates all the way back to 2012, but it goes all the way up to 2024. So students, there's this website. I used to make my kids do it myself, but I'm not here. So students actually collected this data. So they actually went through and they measured their height in centimeters. They measured their foot length in centimeters. They measured their arm length in centimeters. And so this top row here tells you what everything is. So they wrote down, it was a survey. How many languages do you speak? How much, or what do you use to travel to school? How much time does it take you to get to school? Your reaction time, that's like a thing that they have to click the mouse a certain amount of times. So anyways, you'll find all the stuff that you need up here. And so some people have index finger length. Some people have ring finger length. And then some people, depending on where you were, there's some hours slept on a school night. There's some hours slept on a non-school night. There is text messages sent yesterday, text messages received yesterday, hanging out with friends, talking on the phone, doing homework hours, doing things with family hours, outdoor activity hours, video game hours, and so forth. I think that's about it. And so you have to either download dataset A or dataset B, depending on which one you were assigned. And then your goal is to create only 9 slideshows, 9 slides. And in the slide, you need to write down your question. I gave you the question. That should be the first 2 slides, the easiest thing. I gave you the question, and the first one is the title slide. Then you need to take 15 data points. So you need 15 data points and put it into a 16 by 2 table. So if you were just to, if I was to make this bigger, and if I was to do insert chart, insert table. And then if I was to go and make it a 16 by 2, that would be this right here. And so then I could input this table. That's probably the easiest way. You want to actually make sure you label like what X is and what Y is. And so however I gave you the question, so if the question that I gave you was, is there a relationship between foot length and index finger length? You would say foot length, and you could kind of make this bigger by dragging it. Or, foot length, I spelled it wrong. You could do this, foot. There we go, now I can see. All right, so sometimes you could drag this and make it bigger. So foot length is X, And then again, the question was if you had foot length versus index finger is Y. And then you want to make sure that you have the same units. So if you look at the data set, and if I'm looking at foot length, here's one where you're going to have to change because foot length is in centimeters. And so most of these people, 9.5, I would assume they probably messed up. Maybe they meant to put maybe it is 9.5. But like, for example, if you had height, they put 5'10". Well, that means you're 5 foot 10 inches, but that they did not use the correct units. So you have to make sure that they're the correct units. So if someone's 5'8", you have to convert that to centimeters. And you could just look up a calculator online that would take someone's height and convert it to centimeters. So obviously 5'8" is not in centimeters. And so foot length, they should be in centimeters. And then the ones that are blank, obviously don't use those ones. Someone just didn't put that data in. So because this is real students collecting data. And so obviously there's going to be some mistakes. So if you had foot length versus index finger length, index finger is all the way over here. And let's see, where is it at? Index finger. So index finger, you can kind of tell, it tells it right here. It's millimeters. So if your foot length is in centimeters and your index is in millimeters, you don't want to compare those two things. You want to make sure that they have the same units. So all you would do, so like this right here, just kind of looks kind of wrong. If I was just looking at the numbers, most people have like 70, 80, and then this person has 850. So I think something went wrong there. They tried to probably convert it, and maybe they meant to put 85. So 850, that just kind of looks wrong. You could kind of see to make sense of it. You could just type in millimeters to inches, and 850. That's 33 inches. No one has an index finger that's 33 inches. So obviously that person messed up. But you want to convert this index finger to centimeters. So I want really millimeters to centimeters. And so if the first one on the chart says 70, you want to convert 70 would be 7 centimeters. Okay, so the very first person would have a foot length of 22 centimeters, and they would have an index finger of 7 centimeters. So basically, you go to Desmos, and I'm not sure what happened to my Desmos. Here we go. Hit plus table. The first person had an index finger, or excuse me, let's do foot length first. 22 was their foot length. And then their centimeters for their index finger was 7. So that's my first point. And so I just continued to do that until I have 15 data points. So this next person has, each row represents a person. So their foot length was 8, which seems small. And then their index finger, let's go all the way over. Index finger is 5. That seems like they messed up. I'm probably not going to do that one. I'm going to not do that one because 5 millimeters is 0.5 centimeters. Like you basically don't have a finger at that point. I'm not gonna include that data set because it looks like they just messed up. So let's do this. Do the next one. They have an index finger of 110. So what is 110? It'd be 11 centimeters. That's kind of big. That's all right. We'll do 11, and then let's figure out what their foot length was. Their foot length was 29.2. Let's just call it 29. Make things easier. Okay, so and you do that 15 times, and you could zoom out, and you should be able to see your data. And so far, I only have 2 points, but it looks like the bigger X is your foot length. The bigger your foot length, it looks like the bigger your index finger. It kind of makes sense. That's, if you have a bigger foot length, you would probably have a bigger finger. And so you do that until you have 15 data points. And so, you keep going on until you have 15 data points, and then you're going to have some scatter plot. And so once you plug in all your data, you plug it into your slideshow. And then you'd have to tell me the process you use to collect the data. So, it's pretty simple. Is you found a survey of either South Carolina students if you had data set A, or North Carolina students if you had data set B, and you looked at 15 students, and you looked at their foot length in centimeters, and you converted their index fingers from millimeters to centimeters. So you have to tell me all that, how you collected it, because in this actual slideshow, if I was in class, we would have actually collected your actual data. So if you read this, it says we actually measured 16 students' hand spans to the nearest half centimeter and recorded the data. They grabbed a handful of candy, and we recorded the amount of candy pieces each student was able to grab. So this is real data that I've collected in the past from students. We measured their hand span, and if their hand was big, we predicted that they would grab more pieces of candy. And so you have to just tell me how you collected your data. You used a survey. You didn't actually collect the physical data, but you still had to, decipher which data was correct and which data was probably inputted wrong into the survey. So you need a slide for that. And then once you have your scatter plot, you need to actually label which one is X and which one is Y. So going back to what, we only have 2 data points, but if you click on this little graph settings, it says right here, X axis. Well, X axis was foot length. Foot, one word, length in centimeters. I can't spell. Well, I think it's one word. I guess it's 2 words. Foot length in centimeters. And then the Y was index finger in centimeters. Remember, because we converted it. So it automatically plots your labels for your X-axis and your Y-axis. And then the best way to take a screenshot is if you just go to like the search bar and you type snipping tool. And that's how I do it, at least. I don't know the shortcut key on the keyboard. And then I just click and drag, make sure I include my labels. And so you're going to have a lot more points. You're going to have 15 points. Then you could just do, file copy, and you just paste that sucker right into your Google slide. All right, so that's your scatter plot. Then you need a line of best fit. So once you have all your 15 points, you do your Y1 squiggly MX1 plus B, and it plots the line of best fit. You take another screenshot. And then don't forget that you actually have to do your equation. And for this, you could just use the nearest hundredth, which would be 2 decimal places. That's the most likely place to round. So for my slope or my equation, it would be y equals 0.57x minus 5.57, because each of my hundredth place next to the 7 was a 1, so I keep it a 7. And then next to this 7 was also a 1, so I keep that one a 7. So I didn't have to round up. That would be my line of best fit. And so I need to put that also into my slides show. So a separate slide, scatter plot, line of best fit, different screenshot. All right, then you have to interpret what the slope means and interpret what the y-intercept means. Some of these might not make any sense depending on what question that you were given. So especially when it comes to like foot length and ring finger size, like, again, your y-intercept occurs when x is 0. So x is one of your variables. Like if your variable is foot length, if that's your x variable, if foot length is 0, you would have some index finger length. Well, that would mean you don't have a foot, right? That doesn't make sense. So in this case, the y-intercept is 0, or excuse me, the x coordinate is 0 and the y-intercept is negative 49, which would mean that your hand span is 0, but you would grab negative 49 candies. Doesn't make sense at all. You can't grab a negative number of candies. And, if you don't have a hand, you still probably can't grab any candy, right? So you can't grab a negative number, and probably not likely that you don't have a hand. Then prediction. So I Googled, LeBron's hand, and LeBron's hand span is 23.5 centimeters. That represented my X. So for this equation, I erased it, but it was y equals 0.57x plus or minus 5.57. X represented the foot length. So, and then Y represented the index finger. So your index finger would get bigger by 0.57 centimeters. So per centimeter of foot length. So basically, you have to do that in context of the problem. And what I did for this one, again, my prediction is because X represented the hand span, I plugged in 23.5 into X to try to predict how many candies LeBron would be able to grab. And it makes sense here that it's a prediction because, again, LeBron was not actually in my classroom. I just Googled his hand span, and I predicted, based on the line of best fit, how many candies he would probably be able to grab. And I rounded up. I said, roughly 34 Starburst candies LeBron would be able to grab. I didn't actually have the data. We never actually did the experiment. That's why it's a prediction. So you have to, when you write your question for the prediction, you have to figure out what Y represents and what X represents, and then just come up with some type of prediction. Then you have to have a conclusion. And so is it a positive? Is it a negative? Or is it a no correlation? What's happening? How do you tell that? Well, obviously you could just look at the lines here or the data. My data is increasing. As X increases, Y increases. It's a positive correlation. Also, if you look, it gives me an R value, right? My R value is my correlation coefficient. So for the 2 data points that I put in there, it's a perfect positive correlation. You're probably not going to get a perfect positive because you're going to have 15 data points. And the more data points that you have, the more accurate it's going to be. But in the conclusion, you need to tell me, is it positive? Is it negative? Is it no correlation? Some of y'all might have no correlation. Some of the variables might actually not correlate. There might not be a relationship between someone's height and someone's ring finger, or how many text messages you sent yesterday and how many hours you slept on a school night. It's possible that there's no relationship. We tell that by looking at the R value. And then make sure you include the correlation coefficient. Is it a strong? Is it a weak? Or is it just no correlation? You're basically answering the conclusion question based on the correlation coefficient that is given. So it only requires 9 slides. The prediction and the conclusion might be the hardest one. Maybe interpreting. I think these last 3 slides, is going to require a little bit of thought. But we should be able to plot the scatter plot, plot the line of best fit, no problem. And then interpreting, it's kind of difficult to figure out what the slope is actually saying. But I give you this slideshow to try to help you work through all that. All right.